Welcome back to a new data science project. In this video, we are going to create a churn prediction project. We are going to do data analysis, data cleaning, data visualization, feature engineering. We are going to train machine learning models, and at the end, we are going to create a Streamlit web app. You can see the app that we are going to be creating in this video from the screen right now. I'm going to be sharing the dataset link. You can reach to the dataset from the description of this video. Let's start coding. I'm in the Kaggle page of our dataset, and our dataset is about customer churn prediction, and I'm going to take a look at the values and the columns a little bit, but we are going to talk about them more in the code editor. And we have one file with 10 columns, and all the 10 columns are displayed in here, and they are customer ID, age, gender, tenure, monthly charges, contract type, internet service, total charges, tech support, and churn. So our target variable is going to be churn, and we have a classification problem in here. We are going to try to predict if a customer is churn or not based on this dataset. So you can download this dataset from the download button on the page. I'm going to leaving this Kaggle link in the description of this video. You can check the description for reaching to this link, and you can download the dataset from the link. I'm going to be using Visual Studio Code as code editor, but you can prefer any code editor that you want, completely up to you. And I'm going to open my Explorer here. Here I saved the dataset link for sharing with you in the comments and description, and here is the dataset we have. I'm going to start by creating app.py, where our Streamlit app is going to be here, and I'm going to create like notebook.ipmb, and we are going to do analysis and modeling in here in Jupyter Notebook. So I'm going to close these extra pages. For now, we can keep app.py for making notes like this is this. We are going to take notes like this. So I'm going to be keeping app.py open in here, and I'm going to select my kernel as Python 3.11.4, and I'm going to start by importing the pandas. Next up, I will say pandas read CSV. I'm going to make copy from here. I'm going to read my CSV file like this, and we can see it's loading successfully, so we can save it like data frame in here. Next up, we have our data frame ready, and we can call data frame whenever we want to. So I'm going to start by typing dataframe.head, and it's going to display the first 5 rows of the dataset. By the way, it's defaultly 5, but you can extend this list, like you can say 10, and it's going to return the top 10 rows, the first 10 ones. And you can type 2, you are going to get the 2 maximum, the first 2 ones, and also you can type tail for the last 5. Again, defaultly 5, but you can modify it. But I'm going to go by head, and let's keep it defaultly, and let's talk about our dataset. So we have the customer ID column, which is the primary key. I think it goes from 1 to 1000, and we have the age column in here with numeric values. We have the gender column with strings, tenure with the values, and it's month, by the way. We know it from the Kaggle page, and we have the monthly charts in here with the floats, and we have the contract type as strings, internet service as strings, total charges in here, which is the multiplication of tenure and monthly charges. And next we have the tech support, yes and no, and we have the churn, which is our target at the end, which is yes or no. So for the starting, we can call info for having a general look in the dataset, and we can see that we have like 300 null values in here. This is pretty important because if I call data frame is NA, it's going to return me, I will say sum, it's going to return me booleans in this way, it's going to return me the numbers in column-based format, and I will say sum again for seeing the general sum. If I say drop NAs in here, I'm going to drop all of the 300 columns, and it's totally unnecessary because we have values in the other ones. And if we are not going to include internet service in our modeling side, we don't need to drop that 300 data points. So instead of dropping the NA values and dropping my dataset size as 30%, I'm going to fill the NA values by something similar, like I'm going to call data frame, and I'm going to call internet service, and we can see fiber optic DSL. So it's generally like strings. So what I'm going to do is I will say fill NA, and I'm going to give an empty string like this. So I'm not going to have any NA values in the series right now. I'm going to save it as data frame internet service. So when I make this run, I'm going to call data frame is NA sum, and we are not going to have any NA values in our dataset. So we don't need to drop any kind of NA values. Great. Next up, I'm going to call the data head again in here, and actually it's data frame. I saved it like this, and now I want to check duplicates if we have any. So I will say data frame duplicated, and I'm going to call that like this. It's going to return me booleans. I'm going to say sum for seeing the sum of the duplicates. Okay, great. We don't have any duplicates, so we don't need to do something like dropping the duplicates. Next up, I'm going to call data again, and now we can do again. I did the same mistake. I can see that. And now let's see the numerical summary. So I will say data frame dot describe, and it's going to return me numerical summaries for the integer and float columns. So we have customer ID, age, tenure, monthly charges, and total charges. And in the age side, we have the mean of 44, and our standard deviation is 9. Our minimum age in the dataset is 12, and the maximum is 83. And at the tenure side, we can see that the mean tenure is 18 months, and we have the 0 as the minimum and 122 as the maximum. So we have customers like who is with us for like 10 years in the dataset. And at the monthly charges side, we have the 74 as mean, 25 as standard deviation, and the minimum is 30 and the maximum is 120. So at the total charges side, we can see that for sure our minimum is 0 in here because we have the 0 tenure, and we have the mean of 1404. We have the standard deviation of 1571, and we have the maximum value of 12,460. Okay, great. So I'm curious about these correlations between these values. I'm going to do like, I will say numeric columns data, and it's going to be equal to the data frame. I will use select data types, and I'm going to say include integer with, actually we can just say number. It's going to work like this, and I'm going to call numeric columns data. We have this right now. Now I can call correlation on that, and we can see the highly correlated ones. So we have really low correlations in here, and for a quick recap, correlation takes values between -1 and 1. 1 means strong positive relationship, and -1 means strong negative relationship. And we can think like when the value is -1 between two columns, when one is going to be upper, the other one is going to be decrease. Like they are going to move in the different directions. Like let's say you have age and tenure. When age increases, tenure is going to decrease in the -1 scenario. And in the 1 scenario, they are going to move together. They are going to increase and decrease together. Think like age and education. Let's say like you have more age, you are going to get more educated, and it's going to be positive. You can think it like this. And in here, our correlation values are really, really low. Except the total charges is highly correlated with tenure, since we can, actually it's not providing any insight because it can be expected by, we find the total charges by multiplying tenure with monthly charges. Okay, so as the next step, I'm going to call the data again, and let's say we want to do some kind of analysis on these columns. Let's do some group bys, data visualizations, and more. So I want to start by seeing the value counts on the churn column. So I'm going to filter the churn like this. I'm going to have a pandas series, and I will call value counts in here. And this returns a pandas series, just like the group by operations. I'm going to show you quickly, and we can check the type is series. So I'm going to say yes is 883, no is 117. We can plot this using the plot and specifying the chi as, let's say, we want to create a pie chart in here. And we can see our pie chart in here, but we have this y label, it's unnecessary, and we don't have a title. So we can add title to it, like we can say import matplotlib.pyplot, as PLT. Next up, we can say plt.title, churn count on the data. Actually, we can say churn and yes, no, like this. Next up, I'm going to add a y label. It's going to be an empty string for making this count disappear, and I'm going to use plt.show, and we are going to see our pie chart is going to be ready in here after making them run. Great. So the general answer is yes. So the most of the customers are churn in our dataset. Okay, so next step, let's do some group bys. Like, let's group our data by churn and see the average monthly charges. So I will say data frame group by, and I'm going to group by churn, and I will say monthly charge dot mean, like this. And we can see that at higher charges the churn probability is more, and we can do a multi-index group by like this one. We can also include gender at the grouping side. Group by, I'm going to give it a list like churn and gender like this, and I'm going to take the values of monthly charges like this. And let's see the situation by genders. Okay, we can see the results in here. So I'm curious about the tenure side, so I will say data frame group by churn, and I want to get the tenure mean values like this. So at the not churn side, we have a higher value in here. Great. Okay, so I'm going to call it in here too, because I don't want to scroll up every time when I want to look this data frame. Like, I'm going to check this. Now I'm going to group by churn, and I'm going to take the values of age this time. So we are going to get, oh, the values are really similar. Great. So I'm going to do like data frame group by, I'm going to group the data by contract type, and I'm going to get the value of monthly charges dot mean. And we can see that at lower term contracts we have higher charges, as it can be expected. So we can create a plot from this. Again, since it returns a panda series, we can say that plot, and we can specify the kind as bar. So we are going to have a plot like this. And again, we can change this like plt.y label mean price, and we can say plt.x label contract type, and we can add a title to it, like it's going to be contract type average price. So I'm going to add plt.show at the end for making this disappear, and we are going to have something like this. So again, by the way, you can write your findings to your Jupyter notebook, like you can add a markdown and say at the lower terms we can see that the monthly charge average decreases. We can add our findings like that too in Jupyter notebooks if you are going to create any type of presentation. Great. So I'm going to call the data frame again, and actually I think it's enough with the group bys. We can continue with, I guess, I want to see the monthly charts histogram, so I will say plt histogram, and I'm going to pass data frame monthly charges. So we are going to have something like this. And actually we can add plt.show again, and we can add plt title histogram monthly charts. We can add them, and we can see that the histogram, the data distribution. Also, I'm curious about the tenor too, so I'm going to do the same for the tenor, and I will say title histogram of tenor, and I will use plt.show at the end. So actually there's a problem. Let me check the column name. It's tenure. I'm sorry. Now it's going to work out smoothly. Okay, great. Okay, now I'm going to call the data frame again, and we can start to the feature engineering side. I think it's enough for the analysis. We started by loading our data. We checked for the NA and duplicated values. Next up, we take a look at the numerical summaries and the correlation. And in the next step, we talked about the correlation values in here. Next up, we created some charts from value counts and group bys. In here, we can see some group bys we made. Next up, I'm going to take a look at what we did. We created histograms, and now we are going to start to the modeling side by feature engineering. So I'm going to select the columns that we are going to use on the model. So I'm going to call dataframe.columns, and next up I'm going to say, like, we have customer ID, age, gender, tenure, monthly charge, contract type, intern service, total charge, state support, and churn in here. Of course, Y is going to be churn we have. But before that, actually, let's first set Y like churn. And at the X side, we are going to have data frame, and I'm going to take age, I'm going to take gender, and I'm going to take like tenure, and I'm going to take monthly charts. So these are going to be my predictors. Like, I'm going to use them for predicting this. Okay, so next up, we need numeric values for modeling for both X and Y. So I'm going to start by the gender in here. For the gender side, we are going to set 1 for female and 0 for male. So we are going to have numeric values instead of string ones in here. For that, I will say X, and I'm going to filter out the gender from here like this. And we are going to have the series right now. Now I will say .apply, and for say I will say lambda for creating a one-line function. I will say X is going to be 1 if X is equal to the female, else it's going to be 0. So when I make it run, I'm going to get a series like this, and I'm going to run the X again. It's not going to change since I didn't modify this in here. But if I call like X and gender, and if I save it like this and make this run again, we are going to have zeros and ones in the gender column. And we can see the type of these values are going to be, let's do it in here, like X, I'm going to call it head like this, X, gender, let's select a random one, and let's take the type of it. So the type of X is going to be integer right now. We are going to do the same for the Y in here. So I'm going to call the Y head2 closely, and actually let's take a value with no including. Okay, head2 works. So I'm going to say Y, and I'm going to take the churn in here. I will say .apply, and I'm going to say lambda X is going to be 1 if X equals to yes, else no. So I'm going to save it, and we can see that we have a series like this right now again. I will say Y churn like this. And for the Streamlit side, I'm going to be both saving them. Like, I will say in here gender, and 1 is female, 0 is male. And in the churn side, 1 is yes, 0 is no. So we have them. We are going to be using this information when we are coding our Streamlit app, and I'm going to call the Y for showing you we have this integer values. We can check, like, take a random one from this. Actually, it didn't work out. So I'm going to say Y, okay, churn, and I'm going to select a random one, and I'm going to check type on this. It's going to be an integer. Okay, so we have our Y ready, X ready. Now we are going to do train test bit for model evaluation. By the way, if you are not familiar with this machine learning concepts, you can check my machine learning tutorials playlist on the channel where I have more than 40 machine learning tutorials. I explain all this stuff. So I will say from scikit-learn model selection import train test split, and I'm going to say xtrain, xtest, ytrain, and ytest. I will use train test split. X, Y, and test size is going to be 0.2, which means that 20% of the data is going to be in my testing set and 80% is going to be in the training set. And xtrain with ytrain is my training set, xtest and ytest is my testing set. We are going to train our model with xtrain and ytrain. We are going to make predictions with the model we trained using xtest, and we are going to compare the predictions with the ytest. Great. So in the next step, I'm going to scale the x. So we have x values like this in here, but we can see that we have different ranges in both sides. Like in age, we have like 1 to 50. In monthly charges, we have 1 to 100. But in gender, we have zeros and ones. And in the tenure, we have 0, 60. So I'm going to be using this data by scaling it. So I will say from scikit-learn model selection, actually I think it's going to be from processing, import standard scaler. And next up I'm going to initialize my scaler like standard scaler like this. And firstly I'm going to scale the xtrain, like xtrain is going to be scalar fit transform, and I will pass xtrain. But after this, before scaling the xtest, for the Streamlit app, I'm going to export the scalar. If we scale the x completely and then we do a train test split, then there can be data leakage, so we are not going to prefer that. And I'm going to export the scalar like I will say import joblib. Next up I will say joblib.dump, and I'm going to give scalar, and I'm going to export it like scalar.pickle. So I'm going to have the scalar in here right now. So we can add a note in here like scalar is exported as scalar.pickle. Great, so we can continue. Now it's time for the xtest. Scaled xtest is going to be scalar fit transform, and we will give xtest in here. So we have the, actually let's say xtest is going to be scalar fit transform xtest. So I'm going to do that, and we are going to have xtrain and xtest scaled right now. Great. So I'm going to delete them quickly, and we have our data scaled right now. Next up, what we are going to do is we are going to do modeling. We are going to build our classification models. So firstly, I'm going to define a function for getting the model performance. I will say from scikit-learn matrix import accuracy score, which is going to be our metric for evaluating the classification models that we are going to be creating, and it takes values between 0 and 1, and the value closer to 1 is better. So I will say define model performance, and I'm going to be passing the predictions from the model, and it's going to return me like accuracy score on model is this, and I'm going to be using string formatting in here. I will call accuracy score with ytest and with predictions that we will pass inside this function. So we can like to start by logistic regression, but before that I'm going to import grid search. We are going to do hyperparameter tuning on models like decision tree or random forest. So I'm going to be using grid search for the hyperparameter tuning. Next up, for the logistic regression, I will say from scikit-learn linear model import logistic regression, and I will say logistic model. I'm going to take logistic regression from here. I'm going to initialize my logistic regression in here. Next up, I'm going to train my model using like xtrain and ytrain like this. So actually there's a problem, let me quickly check. Okay, I forgot the fit method in here. We are going to say fit for training the model, and I see we have a warning. I don't want to have any warnings, so I will say import warnings, and I will say warnings, filter warnings, and I will say ignore like this, and I'm going to retrain my model quickly. Okay, great, we have our model trained right now. Next up, we can get predictions from it using the predict method like this. And we need to pass a two-dimensional array in here, like I'm going to call our x. We need to give the same data structure that we trained the model, like we need to give age, gender, tenure, monthly charges in the order we create. Like we can say age is 40, gender is 0, tenure is 20, and monthly charge is 80, and our model predicts that it's a churn. From this one we can understand that, and we can reach that one like this. So our model for these values predicts that it's going to be a churn. So I'm going to delete them both, and I'm going to call this on xtest, and we are going to have an array as a result. But since it's already in a two-dimensional format, we can delete these brackets, and we have an array like this. Next up, I'm going to save it something like y predictions, and these are our predictions for the x test. Now we have the actual values, which are the y test, the true values. We are going to compare these two. So for that, I'm going to say like model performance, the function we define, and I'm going to give y predictions in here. And our accuracy score is 0.94, which is a really high score. Our model is doing a great job on predicting the customer's churn or not. By the way, we have a lot of ones and a little bit zeros at the churn side. Let me quickly find. I'm going to find it quickly at the churn value counts. Yeah, here. So we have a class imbalance in here, and we can balance this data set by using methods like smooth. I'm not going to be using them in this video, but if you want to train better models which can generalize better, you can try different imbalanced data handling methods on this dataset for the churn column. I'm not going to do them and keep this simple, but you can do that for better models. So we have our y predictions in here right now. Next up, after logistic regression, I'm going to continue with k-neighbors classifier. So for that, I will say from scikit-learn neighbors import k-neighbors classifier. And I'm not going to train a base model. I'm going to do hyperparameter tuning for optimizing the parameters. I'm going to define a parameter grid in here, and I will say number of neighbors is going to be, let's say 3, 5, 7, and 9. You can extend this list, it's up to you. We can give weights, like it can be uniform or distance, and I'm going to give algorithm in here. Actually, I'm not going to give that, like it's not unnecessary for this one. And now I define the parameter grid. Next up, we are going to set the grid search like grid k-neighbors. It's going to be grid search cross-validation. I will say k-neighbors classifier. I'm going to say parameter grid, and I'm going to set the cross-validation as 5. You can check the machine learning playlist for learning about the cross-validation. But basically, it splits our data into 5 folds. And now I'm going to train it using the fit method on xtrain with ytrain. So we have this ready. Now we can check the best parameters using the best parameters method we have, and number of neighbors is 7 and weight uniform. You can extend this list for trying out different numbers, but I'm going to be continuing with this model, and I'm going to say grid can.predict, and we can make predictions like this right now. I'm going to save them into y predictions, and next up I'm going to call model performance using y predictions from the k-neighbors, and our accuracy score decreased to 0.91. So logistic regression performed better than the k-neighbors classifier. Now I want to continue with a support vector classifier model. We are going to be importing from scikit-learn support vector machines, import svc. And again, of course, I'm going to do hyperparameter tuning for getting the best performance possible. And I will say, by the way, I'm saying best performance possible, but I'm not extending this to make lists. Like I'm not trying a lot of numbers, but still, I think we are getting accurate models for this kind of computational cost. You can increase the lists, like you can extend them, but it's going to be more costly in terms of computation costs, and it can take some more time to train. I don't want that. I want models to train quickly, so I'm not following that path. So I'm going to initialize the base model like support vector mentions. As we see, I'm going to set my classifier like that. I initialize it. I'm going to define parameter grid, and it's going to be like we have C, the regularization strength in here, and I'm going to give values like 0.01, 0.1, 0.5, and 1. We have kernel, and we can give like linear, RBF, polynomial in here. Next up, actually I think this two enough. I will say grid support vector classifier. I'm going to initialize it using grid search cross-validation. I will give SVM with parameter grid, and I'm going to set the cross-validation as 5. Next up, I will say grid svc predict. Actually, we first need to train it, so I will say fit, and I'm going to call xtrain and ytrain. So our model is going to be trained in here. Next up, I will say grid svc the best parameters, and the best parameters are going to be 0.01 for the C, linear for the kernel, and I will say grid svc predict, and I'm going to predict the x test like this, and I'm going to save them to something like y predictions, and I'm going to call model performance with this y predictions in here. So accuracy score is 0.945, so this is the leader by far. Logistic regression was 0.94, and our new leader is support vector classifier. It beat both the logistic regression and the k-neighbors classifier. Great. So let's continue with tree-based models. I'm going to start by decision tree classifier. I will say from scikit-learn tree import decision tree classifier. Next up, I'm going to define parameter grid, and I'm going to say like criterion. We can give like Gini and entropy. Next up, at the splitter side, we can use best and random, and we can create max step parameter, and it can take like none, 10, 20, 30. Next, I'm going to create minimum sample slit. You can extend this lists, by the way, 2, 5, 10. I'm going to create minimum samples leave. I'm going to give 1, 2, and 4. So next up, I'm going to set my grid search like grid tree is going to be equal to the grid search cross-validation. I will say decision tree classifier, initialize it like this. Next up, I will say parameter grid, and I'm going to set cross-validation as 5. So I'm going to make this run using fit method with ytrain. So when this finishes, it finished, I'm going to take the best parameters, and I'm going to make a prediction with it on the y prediction. It's going to be grid tree predict, and I will say x test. So we are going to have an array like this. Now we are going to call model performance and give y prediction, and our result is 0.89, so it's lower than the support vector classifier, and we are not going to use that. So let's also, at the final step on the modeling side, try out random forest. So I will say from scikit-learn ensemble, I will say import random forest classifier. Next up, I will say like random forest classifier model is going to be equal to the random forest classifier, and I'm going to say parameter grid is going to be like we are going to have number of estimators, and I'm going to give it a list like 32, 64, 128, 256. We are going to have maximum features. I'm going to give 2, 3, 4, and I'm going to set the bootstrap, and by the way, it's for replacement, true and false. So we have the parameter grid ready right now. Now I'm going to set grid random forest classifier. Grid search cross-validation will pass RFC model parameter grid, and we are going to set the cross validation as 5, so we can make it run xtrain with ytrain, and it's going to finish in seconds in my opinion. Let's see the best parameters selected. Grid RFC.best parameters, and it's true for the bootstrap, 2 for the maximum features, 32 for the number of estimators. Again, you can extend this list, like you can add 16 to here and try if it's going to perform better. So now what I'm going to do is I will say grid RFC dot predict. I will give x test, and I'm going to save this as y predictions, and I'm going to call the model results, model performance, with y prediction. So it's 0.90. So the best performing one is the support vector model. Let me quickly find that. Here is the support vector here. So we have the grid SVC as the best performing. I'm going to call that. And we have this in here. Now we can pack best estimator from here. And it's our best model in this case. So we are going to export that like joblib.dump, and we are going to export the best model, and it's going to be the model.pickle. So we are going to have that in here right now, and I'm going to note it down like model is exported as model.pickle. Also, before the Streamlit app side, I'm going to call x.columns, and I'm going to write the order of the x like order of the x is going to be this. I'm going to just copy this one like this. So we are finished with the Jupyter notebook. I'm going to save it and close that. But before closing, I want to summarize what we did on the machine learning side. I'm going to come to here to the feature engineering side. We firstly started by, let me quickly find that. Yeah, here. We first started by selecting the y and the x that we're going to use. And we started by encoding our categorical values, like we changed gender and the churn, yes and no's. Next up, we applied train test split with setting the test size as 0.2, and we scaled our data. After scaling the training data, we exported our scaler. For not having data leakage, we scaled our test values in here. And next up, we define a function for getting the accuracy score with the predictions from the models. We train a logistic model, we get our results, we train the k-neighbors classifier model, support vector classifier model, decision tree classifier model, and random forest classifier model. And the best score was on the support vector classifier, so we exported it using joblib dump method as model.pickle. Now we can continue with the Streamlit side. We are going to create an interface, a web app for users to get predictions from our model. So users are going to enter their values and they are going to get the information about churn or not based on the values of age, gender, tenure, and monthly charges. So let's start. We will say import Streamlit as st, and we will say import joblib, and we will say import numpy as np. Next up, we are going to give it a title like churn prediction app, and I'm going to use divider after that. I use dividers a lot when I'm coding on Streamlit because I like how they look. I believe they make apps look pretty better. Next up, I will say like streamlit.write, please enter the values and hit the predict button for getting a prediction. And I'm going to use divider after that, and now we are going to take the inputs, like the order is going to be age, gender, tenure, and monthly charges at the end. So I'm going to take the inputs like this. I will say age is going to be like, I'm going to say Streamlit number input. I will use like, let's say enter age, and minimum value can be, let's say 10, and the maximum value can be 100, and let's set the base value like 30, and I think it's enough. Next up, I'm going to say like continue with the numeric one. I will say tenure is going to be, I will say in here Streamlit, and actually let's continue with the order. I will say gender, and it's going to be Streamlit. We are going to use a select box in here, and it's going to be, the label is going to be the enter the gender like this, and I'm going to give the options like male and female. Okay, next up I will say if gender, and I'm going to say gender selected is going to be like 1 if gender equals to female, else 0. I think it's correct right now. Next, actually I'm going to cut that, and we can do this operation after the selection of all inputs and the button. So I'm going to continue with the tenure, and it's going to be like streamlit.number input, and I will give like enter tenure, and it's going to be minimum value is going to be like 0, and maximum value is going to be like 130. I remember the maximum value like that. A step is going to be, let's say not step, let's say value, and 10. So next up I will say monthly charge, and I will say number input again like this, and I will say in here enter monthly charge, and I'm going to say minimum value is going to be 30, maximum value is going to be like 150. Okay, so we have that. Also I'm going to cut the gender from here and add it at the low side, because these three are the number inputs. It's going to be looking better if we just add them together like this. Next up, I'm going to load my scalar. I will say divider. Now I'm going to load my scalar and model. joblib.load. Firstly, the scalar. So I will say scalar.pickle, and I'm going to load this on scalar like this, and I'm going to load my model like joblib.load model.pickle. Also, we can add it to the top for making it look better on the code side like this. And now what I'm going to do is I'm going to create a button. Like I'm going to say streamlit.button, and predict label is going to be this, and let's set this like predict button, and we will say if predict button, then we are going to do some actions, but I'm going to write the else firstly. Please enter the values and use predict button. So it's going to work if the user don't use the predict button that we define in here, and if the user uses it, then we are going to do, we can say like gender selected is going to be 1 if gender equals to female, else 0. Next up I'm going to say x is going to be like the taken features we have, like in the same order with this, so age firstly. Next up the gender, the new gender, 1s or 0s, gender selected. Next up tenure and monthly charges like this. So we have our x in here. Next I will say x array is going to be scalar transform, and I'm going to pass x1 with brackets, actually not x1. Let's make this x an array firstly on something like x1 since we wrote it. So numpy.array x. Next up we are going to have x array in here, and I'm going to say like we can get predictions from our loaded model right now using like prediction, and in here what we are going to do is it's going to be equal to the model.predict, and we'll pass our array right now, and we are going to select the first element from it. Like remember from notebook, we are going to reach the value inside the array. And we are going to say predicted, and it's going to be like churn if prediction equals to 1, else it's not going to be not churn. And at the end we are going to say streamlit.write predicted like this. So we can say like, we can use an f string predicted, and we can say like brackets in here. So remember, model generates outputs like zeros and ones, and in here I remember like 1 is yes, 0 is no. So we transform the model output to a string right now in here. So I'm going to save it, and we can do like let's say yes and no instead of them. So I'm going to save it, and now after saving I will say streamlit.run, streamlit run, not dot, app.py, and it's going to be working on this URL. It's going to get opened on the browser. If it's not, you can just use this address, just copy that and enter it in your browser for reaching to the web app that we just created. And I'm going to be re-recording on that screen right now. So I'm in the Safari right now. You can see that I'm in the localhost page. You can use any browser that you want. And in here we can see that we have the Churn prediction app. And let's try our app with making a prediction and see if it's working. So it says, please enter the values and hit the predict button for getting a prediction. And at the low side we have please enter the values and use the predict button. Okay, so let's add like, I'm going to enter the age as 50. I'm going to add the tenure like 20, monthly charge as 60, and gender as male. So let's press predict. So predicted yes. Now we can get predictions from our model, and let's make it prettier for a little bit. Now in the code I'm going to make 2 changes. I will say after predict button I'm going to add a divider, and if predict button, before this I'm going to add streamlit.balance. So I'm going to save that, and I will be re-recording in the Safari in a second. So here I am at the browser. You can see that it says source file is changed. So I refreshed it. Now we have that enter the values and use the predict button after the divider. Great. And I will say 4D. I'm just entering random values 10, 50, and I will say female this time, predict. Now we have the balloon effect whenever we use the predict button. Great. So our web app is working perfectly with the model we created. Let's summarize the Streamlit web app for the ending of this coding tutorial. So we can talk about this Streamlit app right now. I'm going to be deleting these comments, and we import Streamlit, joblib, and numpy at the start. Then we load our scaler with our model. Next up we give a title like Churn prediction app. We use dividers for a better look, and we write please enter the values and hit the predict button for getting a prediction. Next we take the inputs from the user and we define a button for users to use. And then if button is not applied, we write please enter the values and use the predict button. And if the button applied, we say transform the gender selected as 1 if the gender is female in the same way that we created on the notebook, and else 0. Next we define our x, we turn them into array. Next up we use our scaler for transforming the x we have, the x1, we set it as array, and now it's x array and it's 2-dimensional. Next what we do is we say prediction, we use the predict method from the model we loaded up, and we take the first one for reaching to the value, and remember that it's going to be yes if the prediction is 1, which means churn, else no. So we define the predicted in here. Next up we add a little bit effect if the button is used, and we use streamlit.write for the predicted value, yes or no. So our data science project is completed with this step. Now we are going to go to the outro, but before that, if you watched to this minute, I really want to say thanks, and I will be really happy if you can like the video and I'm going to be reading the comments, so if you want to share your thoughts in the comments, I will be really happy to talk with you in the comments. Thanks again, and let's get to the outro. Thanks for watching this data science project. I'm sharing new data science videos every week on my channel. You can subscribe to my channel for more videos like this. I have a data science projects playlist where I have more than 30 projects just like this one. You can check that playlist from the cards of this video or from the link in the description. Have a great day.